Hey, how's it going? Welcome to lesson 4.1. This is the first lesson of Unit 4, and here's what 4.1 says. I can distinguish among elements, compounds, pure substances, and mixtures. If we look at our list here, we're at the top. This is the first lesson, again, of Unit 4. So let's toggle back. Let's get the lesson started. So as I look at descriptor 4.1, I see lots of vocab. Okay, so here's vocabulary word number 1, elements. Here's number 2, compounds. Here's number 3, pure substances. And then here's number 4, mixtures. And what we're going to do today is we're going to define every one of these words here in just a moment. So to begin to understand these words, something should be given to you in class. And hopefully at the beginning of Unit 4, you should have received a periodic table. That's what this is. Okay, so let's go ahead and label that just so we remember. This giant table is called the periodic table. And it's comprised of elements. So elements are the building block of nature, and everything in our existence is made from these building blocks here, okay? As we look to the right, we see a classifying matter flowchart. And even though elements are here at the bottom, what we really want to realize is that every type of combination is possible because of elements themselves. So even though elements are the true building blocks of nature, on a broader scope, what we say is that our Earth is made up of a word called matter, okay? So physical substance. Then this matter can be broken down into two subcategories, pure substances and mixtures, which we'll go over today. And pure substances can be broken down even further down to their components, elements or compounds, and we'll talk about these two words at a later date. So at this time, take a look at the photos here underneath. They'll be kind of quite important here in a second, and I really want you to focus here on these two on the left, okay? So the first word we need to define is element. So what is an element? All right, so we'll define element, and you want to write this down as, call this the building blocks of nature. Something we can add is that elements are built of a word called an atom, and they're built of atoms of the same kind. So when you get a grouping of atoms that are all the same, what you end up getting is an element, and from these elements we build nature and physical things. So when you look at a photo of an element, we see that everything is the same kind. Notice it's a single color. There's nothing mixed in, and we kind of see that even though it looks like copper pieces are kind of dirty, that truly inside it's all the same type of particle. So now it's time to define the word compound. So here's a compound, and as you look, we see that the particles are definitely kind of jumbled together, but more importantly, we see that there's all different colors, right? There's a black one, a red one, and a white one. So we kind of dish this sense of kind of a single color, and we see that now we're starting to combine different elements together, right? So when we define compound, here's what we're going to write. Two different elements fused or joined together in a specific ratio. So compound now is two different elements fused / joined together in a specific ratio. And what I mean by ratio is that if there were two, like element A and element B, it could be a 1 to 2, it could be a 1 to 3, it could be a 2 to 3, something like that, and thereafter, right? If we looked at this compound here of different particles, what we'd figured out is that this compound has a specific ratio at its core, and it would be one of these types of options that we would find. All right, so now let's kind of scroll back up to our flowchart. And I think after defining elements and compounds, the word that we should now define is mixture, okay? So what is a mixture by definition? A mixture is going to be two types of elements. So we could say element A plus element B. And it could be in a bowl or something like that. You could just combine two different substances, right? That's what a mixture is in a general sense, right? When you bake a cake, you're combining sugar, flour, eggs, yeast, a whole host of things. You're forming a mixture of different items, and that's exactly what we kind of think of in a chemical sense also, okay? So it could be two types of elements. So we just called it element A and element B. You could also mix together an element plus a compound. And also you could mix two different compounds together. That would also constitute a mixture. So we'll call this compound A plus compound B. And in the next video, what we'll do is I have some particle drawings of different types of elements, pure substances, mixtures, and compounds. And when you see it and we go through it together, I think that these definitions are really going to kind of have some weight to them, and you'll kind of be able to visualize what we're talking about a little bit better. All right, so now let's kind of scroll back to the top. We have one last definition. And now the definition that we have left is pure substance. So something I want you to realize also is that if a mixture is combining two things, a pure substance is going to be the opposite, okay? So these are opposites of one another. And if a mixture combines two different things, a pure substance is going to be either just exclusively an element, a single element, we could say, or it's going to be exclusively a single compound. Again, a pure substance is the opposite of what a mixture would be. At this point in time, you can stop the video and move on to 4.1 part 2. But if you'd like to hang in there, I would like to extend some information further about these topics that will be quite helpful in the future. So as we look at our classifying matter flowchart, something we didn't talk about yet is the difference between homogeneous and heterogeneous. So again, a mixture is either two different elements combined, an element plus a compound, or two different compounds combined. And homogeneous and heterogeneous has to do specifically with the visual look of how these things combine. When we have a visual mixture of things that looks uniform throughout, so as I look at the hot tea, I can't see any types of different lines or chunks of anything, right? We definitely know that there's tea, sugar, and water in there. So we know that there's three items for sure mixed together. We call this a homogeneous mixture. Homo meaning the same. And again, when we know that there's different elements or compounds combined and we can't see specific pieces, then that's going to be a homogeneous mixture. So on the flip side, a heterogeneous mixture will be a mixture where we see clear separation of the elements or compounds from within it. So this is oil and water. If you let oil and water sit, it separates, it creates kind of like a line here. And we definitely see that, okay, these are mixed together, but we can definitely see clear separation between the two compounds. So if we think of a common household item, if you ever made oil and vinegar salad dressing, the first thing you want to do always is shake it up before you put it on your salad because, again, salad dressing is a majority of oil and water, and those things will separate. And again, even though this is classified as a mixture, it's classified as a heterogeneous mixture. We see chunks in there. We see definite differences from within. But again, two different items, oil and vinegar, hence we classify it as a mixture. So the last thing I want to leave you with today is some photos of these words that we defined today. And you can pause the video at each one of these photos and kind of investigate on your own, although I will give you some information of each, okay? So let's take a photo of some elements, okay? So here's an interesting graphic I found. And this is a periodic table of elements, and as you notice, each one of these elements has a photo, okay? So if we got this to blow up, what we'd figure out is that every element almost looks different, okay? And as you kind of move from left to right, here on the right, we have gases. We start to get into a section called the metalloids here, okay? So these are non-metal metalloids here, which means a mixture of metals and non-metals. And then from about this section and left, you have a bunch of different metals. And just notice that, again, they're all unique. They have different colors. They have different types of properties, we could say, right? Some are more brittle, some are more malleable. Some conduct electricity, some don't. Some are gases, etc., etc. And again, you can pause the video and kind of look and investigate further. Hydrogen's kind of a cool one here. So we see some aurora borealis. That's like the northern lights. You can look that up. So again, just pause it and take a look at this one. So the next word we defined today was compound, okay? And here are some particle drawings of a compound. And what you notice about all these compounds is that the colors are all different, right? So here's a carbon and a hydrogen. Notice that this tiny little line represents a bond. And again, it's two different elements fused or joined together, right? Two different elements fused or joined, right? Pink and then green. So you got your hydrogens, oxygen. You got your nitrogen, hydrogens, H2O2. Again, two different elements fused together. All right, so let's keep moving here. Let's move on to a pure chemical substance. And again, when we think of a pure substance, what you have to think about is that it's either going to be an element by itself or a compound by itself. So sugar is made up of elements, but sugar is a singular type of compound, and this is pure sugar. There's no other compounds mixed in. It's just simply a pile of sugar. Water is two hydrogens and an oxygen in a compound form, right? They're fused together. There's no other compounds here shown, right? There's no food dye, coloring, sugar, anything in this water, just pure water. And because there's only a singular compound, that's why this is called a pure substance. Same thing we could go as for baking soda. We could also have pure elements. So a sheet of tin, there's nothing else in there but tin. A pile of sulfur, there's only sulfur. Or maybe a pure diamond, right? There's only pure carbon in this entire structure here, as we can see. All right, the last visual I want to show you today is of a chemical mixture in a particle sense. And again, we went over the words heterogeneous and homogeneous. Remember, homo meaning the same, uniform throughout. And as you look at this photo, we clearly see there's two types of particles. Notice that they're not fused together, right? This is not a compound because of that. But notice that everything looks very symmetrical. It's uniform throughout. So visually, this is like our cup of tea. We can't see a clear difference from the outside. Whereas when we have a heterogeneous mixture, something that's different throughout, this is kind of like your oil and water concept, okay? Here's our water. Here's our oil. They've separated from one another, and they'll continue to be separated.